Okay, so I'm going to add support for a couple of MOV instructions that I've missed so far for moving between general purpose registers and vector registers. So those are MOVD and MOVQ, where D is D word and Q is Q word for the general purpose register. I won't be supporting MMX at all, so I'll just be going through SSE2 down to AVX512. And then with MOVQ, there's actually another instruction here, which is actually two vector registers. But in the case where it's where one of them is a memory operand, this actually gives a shorter encoding than the other one for the same behavior. So this is the one that I'll be using for that encoding. And then, of course, I can also implement this encoding for the two vector registers as well. So we'll start with MOVD up here. So we'll go to MOV SSE. And down at the bottom, we'll just add these. We'll do MOVD, and the operand encodings are always RM or MR. So we'll do XMM 0 with ECX, and then we'll have the memory operand. Then we'll have the same one, but with the operands flipped around. Then we can have the VEX encodings, which is the same thing, but with a V in front of the mnemonic. And then for the EVEX encodings, we'll just use a high 16 register to force that encoding. Then we'll take a copy of these for MOVQ. And for these are quad words, so we need to do RCX for these ones. Then down in the other MOVQ instruction, again, ignoring MMX here, just going from SSE2, we've got two vector registers for some of these forms. So we can say, for example, XMM 0 to XMM 1 or whatever. So we'll just create some encodings for those as well. So we do MOVQ with, let's say, XMM 0, XMM 1. Then we'll do V as well. And then we'll do V with a high 16 register. So I think that should be all of them as far as I can see. So let's just go and regenerate those listing files. So this will be .lst. Okay, and now we'll just go and create all of the encoding tests. So we'll just copy all of these ones in first. We've got encoded test, MOV SSE, add all these in. So these just need to come into the test as the op. These are all going to match on X word, and we'll do V0 to CX, NA. Let's do a comment for these. Okay, so these ones with square brackets need CX to be memory access. And then for these two, and these two, we just need to swap the operand order. Okay, and then we need to do a copy of this for MOVQ as well. And then finally, we just need a couple at the bottom here, which are also MOVQ, but these ones are V0 and V1. And then we've got VMOVQ, and then VMOVQ again, but this one is a high 16 register. Okay, so let's just take, we'll go over to the encoder and find DQU64 and just add the ops here. So we've got op MOVD, VMOVD, And then we've got the same ones, but this time with Q. And then we'll just go and add some empty form tables as well. So DQU, we'll put them below here. Okay, now let's try and run the tests. Okay, so we couldn't match a form, so let's start filling out the forms. So I'll just fill out from this table first, and then Nazem is going to select some shorter encodings for memory targets. So like if the source or the destination is a memory encoding, it will actually use the other MOVQ because it will produce a shorter encoding. So I'll fix those as like a separate step. So ignoring MMX here, we'll just get those off the screen. Basically, we've got a prefix of 66, and then we've got the secondary opcode map, and then 6E for the first one here. So we're basically saying that we're going to match always on X word for these. Op-N for this is op-N register memory. Op1 will be a vector, op2 can be reg or memory. We got a prefix of prefix 66. Map is the secondary one, and then opcode was OX6E. Then we need another one for the opposite order of operands, so this is op-N MR. And for this one we have reg or memory, and then we've got VEC. And this is the same thing, but I think this one was 7E. Yes, 7E. So we just change that 7E. Okay, let's just run these tests again. So now we're getting stuck on VMOVD instead. So let's go to VMOVD. These ones are going to be family VEX. And these all have the same prefix opcode map, W0, but MOVQ, when I get to that one, has W set to 1. And for MOVQ, I'll need to make sure that it's encoded as Q-word so that we get the Rex prefix as well. So I think that's okay for VEX because they're still 6E and 7E as the opcode. So we'll just do the same for EVEX down here as well. And EVEX doesn't support any kind of like opcode masks or anything like that in this case. So let's just run these tests. Okay, so now for VMOVD, we're getting incorrect things for the EVEX test. That's probably because the EVEX tests, I haven't changed them to use the high 16 register. So we'll just go and change that now. Okay, so MOVD works as I'd expect. So let's just copy this stuff for MOVQ because I think it looked the same, with the difference being that the enc width here should be Q-word. And then for these ones here, the EVEX for MOVQ needs to have W set to W1. And let's see, does MOVQ need it for... Yeah, so VEX and EVEX set W1. So I'll just do it on these two as well. I've got W1. And I think that is the main difference there. So let's just go test. So MOVQ, okay, so this is a case where it's using the other MOVQ for the shorter encoding. This one here, MOVQ, okay, this is also shorter encoding. This one is just incorrect. So this is register, this is the RM encoding with the second operand being a register for MOVQ. So with MOVQ, this is the VEX encoding by the looks of it. So VEX is from here. And we've got, this is MOVQ, so it should be this one. So we've got 660FW16E. So VEC, this is 6E. We've got all the correct stuff here. I wonder if this is just... I've got XMM 0 RCX. So we've got C1, which is correct. We've got 6E, which is correct. So there's something in here. Is this because W1 is not being set for VEX at the moment? Okay, so we'll go to W. Okay, yeah, so I haven't actually implemented W for VEX 3 right now. So what I need to do is say that if the form.w is equal to W1, then we want to use VEX 3. And in that case, if form W equals W1, then we need to set W equal to whatever that W bit is. The W bit is the top bit, I think, so it's the same as here, same as the EVEX one, so we'll set that to 0x80 to set that bit. And actually, let me just check, just for the... Okay, let's just change these as well to match the same style. So this will be byte as the 0, 1 here, and then Z can also be the same thing. Okay, so let's try that again. Okay, so now it's just the short encodings for these, which are actually using the other form. So if we go to the other form now, we don't care about MMX, so we'll start with SSE2 here. SSE2, okay, let's just fill in the forms for these as well quickly. So the forms for these are that in the normal one here, we want, is it going to use, okay, well let's just match on one and see which one it's going to use. So it might use 6E, for example, because that's the first one. So we'll do VEC, and then this one will also be VEC in this case. So this is for the two operands being VEC case. So in this case, it's 7E or it's D6, but we've still got a prefix of 66, and opcode map is the secondary one. For this one, it's F3 as the prefix though, so we'll just leave it as this and see which one it's trying to select here. So for MOVQ with 2 registers, it's actually selecting the F3 7E version, because that would be the, I guess, the shorter encoding. So we'll go and just implement that. So this is 7E is the opcode, and then the prefix was F3. And then we don't need enc_width as being keyword here, because it already is, the encoding doesn't require that for this case. Okay, so that takes care of that one. Then we'd have the same problem with the VEX and EVEX ones, but let's just fix these ones first. So in the case where it's a memory operand on one side with a VEC on the other side, we're actually using these shorter encodings. So I think what I'll do for this is just split this out. So the first one is using opcode 6E, which is this one for MOVQ. So for this one, we'll just say that we're not going to match on memory for this one, and for this one, we'll only match on memory. In this case, we got F3, and we don't need enc_width to be keyword here. Then we've got, oh, this is a 7E as the opcode for this case. So that takes care of that one. Then the other one is that we've got memory on the other side. And this is, instead of 7E, it's going to use D6. So for this case, we'll do a copy of this one. We'll take memory out of here, and we'll just leave memory in here. We won't have keyword as the enc_width anymore. This was D6, and then the prefix is still 66 in this case. So let's just see how that goes. Okay, so now we just have the VMOVQ cases. So for VMOVQ, where I am using 6E, which is these ones here. So this is VEX and EVEX. This particular encoding that it's changing here is the VEX one, because EVEX will only be selected if it's needed for some feature like a high 16 register anyway. So this is the one that needs to be split out. So we'll take out mem here, take out reg here. This one now needs a prefix of, well, I can't tell from this, so we'll just go to here. So this is prefix of F3 still probably. And then 7E. And this one, I don't know if we need W sets for this one. No, we don't, because it's not UVEX. Okay, so it wants two. Oh, yes, okay, I don't need to set W, so I should take this one out. Okay, so now it's just the final short version. So that is for probably VEX again. Yep, that's VEX again, so we'll just copy this one, take memory out of here, take reg out of this one. These ones will now be not setting W for the memory version. And 7E changes to D6 again. Okay, so now it's just the VEC to VEC forms that I need to do. So we've got, this is for VMOVQ though. So for the VEX version, I'll keep it up here. We'll just say this is RM encoding, let's say, and this is VEC. For this one with VEC and VEC, we'll do this 7E one. So this is F3 with 7E again. And hopefully that's correct. In this case, VEX it ignores the W bit, so we'll just get rid of that. Okay, so now it's on to the EVEX one. I'll just copy this one. So here we've got VEC on this side, and we'll have a look at this one. So we'll say 7E, and it's got the W bit set. Prefix is F3, so let's change this to F3. Okay, so this looks correct except for maybe the prefix. No, it's not the prefix. The prefix is correct. So let me just check this. So we've got EVEX is F3, 0F, W bit is set, 7E is correct there. Map is the secondary one. So what is being, this is probably the operand encoding. So we've got C, where C is reg, then memory. So this should be RM. Okay, so that's MOVD and MOVQ.